Consider the continuous probability density function defined by y equals 0.5x plus 0.65 on the interval where x ranges between negative 1.3 and 0.7. So this is a slightly more interesting problem. We've got a little more going on here. It's not just a straight line straight across. Notice that the expression for y is a little more complicated. Here it's saying y equals 0.5x plus 0.65. Okay, that is the equation for this function. What that means is that the value of y, the height of the line, changes for each value of x. And the picture kind of illustrates this. So for a certain value of x, say negative 0.6, we'll get a certain value of y, whatever this value is right here. This rule tells us exactly what y it is. Okay? If we have a different value of x, say negative 0.2, we get a different value for y. This rule tells us exactly what it is. All I have to do is tell it what x it is, and then compute this equation, and then I get the corresponding y. Okay? And we do have limits, right? We can't just plug in any x. The x has to be between negative 1.3 and 0.7. And we could see that here. Here's negative 1.3, this left side. And here's negative or positive 0.7. So the graph stays within those bounds. Okay? And also, again, this is a probability density function. The problem is telling us that it is, which means the total area underneath this, this line has to be 1. So the first thing we want to compute is the probability that x is less than negative 0.1. We want to compute the probability that x is less than negative 0.1. So I'm going to first find negative 0.1. It's always a good idea to draw a little picture of the region you're looking for. It doesn't have to be exact. Mine looks very nice because I'm doing it on a computer, but a quick sketch will do. You just want it to give you the idea of what's going on here. Okay, so we found negative 0.1. We're interested in the values that are smaller than negative 0.1. Smaller values are to the left. So I want to find the area of this shape here. Okay, because probability equals area when we're dealing with continuous probability density functions. So I need to find the area of that shape. Now, this shape is a little different than the shapes we've been dealing with, right? That's not a rectangle, that's a triangle. So I need to make sure I use the right formula for that. The formula for the area of a triangle is 1/2 times base times height. I get an extra factor of 1/2 in there. Okay, so let's start by finding the base. So we find the base just like we do for a rectangle. Okay, I'm going to take the bigger number and subtract the smaller number. So the bigger number is negative 0.1 minus the smaller number, which is negative 1.3. And that is going to be 1.2. So that is my base. Now the height's a little trickier. With the rectangles we were dealing with, because it's a rectangle and you just have that straight line up top, the height was always the same. But here, this triangle, this top edge here is slanted. Right? That top edge there is slanted. So what is the height? Well, when you're dealing with the height of a triangle, you mean the place where the triangle is the highest. Okay? In this case, because we're only dealing with this smaller shaded in triangle, that would be this right edge. Okay? That's where that triangle is the very highest. Right? How high is it? Well, maybe it looks like it's around it's around 0.6. Are we sure though? In order to be sure, we can plug into this. Remember, this tells us for any value of x what the y is. And y is kind of the height here. Okay? So to find this height, I'm going to find the y value of this edge. So I have 0.5, and then I multiply by the x value of that edge. Now this edge here is at negative 0.1. That's the location. So that's the x value. Negative 0.1 plus 0.65. Okay? This is going to give me my height. If I plug that into my calculator, negative 0.5, I'm sorry, positive 0.5, 0.5 times negative 0.1 plus 0.65, I get 0.6. Okay, so it is what it looked like. It was actually 0.6. But you have to be a little bit careful. It's not always going to be easy to just look at it and see how tall that triangle is. So that's 0.6. So that's our height. So we have 1/2 times base times height. And that's 1/2 times, our base was 1.2, and our height was 0.6. So let's multiply that together, and we will get the probability. So that's 1/2 times the base, which was 1.2, times the height, which is 0.6. We get 0.36. That's the probability for that first section. That's the probability that for this experiment, the outcome would be smaller than negative 0.1. 0.36. There's a 36% chance. Okay? Now, we still have one more probability to calculate. That's the probability that x is greater than negative 0.1. So let's get a clean board here. Okay, and just as a reminder, this was, what was that, negative 1.3, and this one is 0.7. And the function itself is y equals 0.5x plus 0.65. Okay, now we want to find the probability that x is bigger than negative 0.1, right? That's the second probability we want to find here, that x is bigger than negative 0.1. So let's start by drawing that out. Okay? So here's negative 0.1, the same value from last time, but now we want the outcomes that are bigger than negative 0.1. So that's over here to the right. Okay, so as usual, probability equals area. But in this case, this shape is a little bit harder to work with, right? It's definitely not a rectangle. It's also not a triangle, right? Technically, this is a trapezoid. Now, you probably do not remember the formula for a trapezoid, and that's okay. I don't expect you to know it. So how do we go about actually finding this area? Well, the key here is realizing that the area to the left is what we've already found. This is the probability that x is less than negative 0.1. That was the 0.36 that we've just found. Okay? This is the probability that we're looking for, this region. That's probability that x is greater than negative 0.1. Together, that's all the area that's underneath that function, right? And so together, what must they be equal to? Probability that x is less than negative 0.1 plus probability that x is greater than negative 0.1. That's got to be equal to 1, or 100%. right? Because it fills that whole space. Which means if I subtract this guy away, then what I get is probability that x is greater than negative 0.1 is equal to 1 minus probability that x is less than negative 0.1, and that was 0.36. Okay, so my final probability, if I plug that into my calculator, 1 minus 0.36, I get 0.64. So there is a 64% chance that if I run this experiment, the outcome would be in this region, that the outcome would be bigger than negative 0.1.